Okay, I see people flowing in. I think we're going to get started. Hello, welcome. Welcome to today's webinar from Paper to Pixels, Digitizing Water Quality Data Collection with Posit and Esri Integration, brought to you by the R Consortium. The R Consortium supports key organizations developing R infrastructure through grants and sponsorships worldwide. Please visit our website to learn all the details and how your organization can become a member. My name is Jesse Kasman, today's moderator. I have just a few housekeeping items before we begin. You can ask questions. We encourage you to ask questions. You're part of the R community. We want to hear from you. Just find the Q&A icon and enter your question that way. Near the end of the webinar, our speakers and also our friends from Esri will try and answer as many of your questions as time allows. In fact, we have two people from Esri who are here to respond to questions as needed. That's Nick Ginner, Senior Product Manager on the Analytics and Data Science team at Esri, and Josiah Perry, a Senior Product Engineer in Spatial Analysis and Data Science at Esri. Josiah is also the Vice Chair of the ISC at the R Consortium. That's the Technical Steering Committee. Okay, let me hand it over to our speakers from the Department of Environmental Quality from the Commonwealth of Virginia. That's Joe Famularo, Analytics System Administrator, Maddie Moore, GIS System Administrator, Emma Jones, Water Monitoring Supervisor, and Scott Hazinger, Water Monitoring Supervisor. Thanks to all of you. Joe, I believe we're starting with you. Please take it away.
Thanks, Jesse. And welcome, everyone. Thanks for taking the time out of your day to join us. Today, we're going to be talking about a project that we at DEQ have been working on for a number of months, where we have taken a legacy process for collecting water quality monitoring data and moving that legacy process into a digital platform through an integration of our Posit environment and our Esri environment. I'm Joe Famularo. I'm the Analytics Systems Administrator, as Jesse had mentioned, joined by Emma Jones and Scott Hazinger, two of our water monitoring supervisors, and Maddie Moore, GIS or our GIS Administrator. Today we'll begin with an introduction to DEQ and water quality monitoring. We'll go over the history or historic process for collecting field data during lake monitoring. We'll provide a summary of our analytics architecture and how that has changed throughout time to support some of the changes in this water quality monitoring process. We'll touch on the integration between our Esri and Posit products to support this new water quality monitoring data collection process. And then we'll briefly talk about next steps in the future of this effort. And with that, I'm going to go ahead and hand it off to Emma Jones.
Thanks, Joe. Emma Jones here. So just to remind everyone, Scott and I are coming to this project as part of the water quality monitoring team. And right off the bat, we want to thank the rest of our field team who have helped us implement all these programmatic changes we're about to discuss, because it's not easy to change protocols quickly, and they've done a fabulous job just coming along for the ride. This is also a good opportunity to show you all what water quality monitoring actually looks like, with photos of our field team out there collecting water samples sort of in the wild. Next slide, please. Virginia DEQ is tasked with protecting and improving water resources throughout the Commonwealth per federal and state law. To do so, DEQ operates several water monitoring programs that center around maintaining Virginia's water quality standards. These programs focus on monitoring and assessing water quality, limiting point source pollutants, and promoting the implementation of practices that help mitigate non-point sources of pollution. We're going to focus on the water monitoring and assessment program, sort of up in the top right-hand corner here, highlighted in that green circle. Now, these programs are key to informing the status of subsequent water quality programs in our so-called water wheel. Critical to sort of any analysis process is the reporting out of those findings, which we're going to touch on with regards to Virginia's biennial integrated report. This integrated report is one mechanism that DEQ uses to communicate water quality conditions and trends across the state, in addition to listing and prioritizing impaired waters to help focus cleanup efforts. Next slide, please. Now, in order to acquire and analyze water quality data to generate our integrated report, DEQ first needs to plan and then budget for all of our monitoring activities that are going to be accomplished over any given monitoring year. And historically, that's been managed through Excel spreadsheets and SAS. As part of the planning process, these vast monitoring networks that service multiple survey programs are broken up into what we call monitoring runs, which are essentially sites that are close enough together that we can manageably collect within one day. Typically, our staff have completed the monitoring run planning component using browser-based Google Maps. Now, on a given sampling field day, our monitoring staff schedule a run in our comprehensive environmental data system, or our internal database that we're going to keep referring to as KEDS. The crew then heads out in the field and completes the sampling effort by writing down field measurements onto pieces of paper that they are reading off of our measuring equipment, as well as collecting water samples into bottles, containers at each site. They repeat this for every site on a monitoring run, and that can be anywhere from 2 or 3 sites to upwards of 12 or more. Once they're back at the office, the staff then re-enter this data from their piece of paper field sheet one more time to get it digitally into our database, KEDS. This process happens daily at DEQ to meet different sampling quantity and frequency needs, and in order to properly assess the data for our various monitoring programs. As we approach any given integrated report cycle, this vast amount of field and chemical data then that have been collected over the past 6 years are then queried out of our KEDS database using SAS, or more recently R. And numerous QA/QC procedures are implemented on the data before they ultimately end up in R-based Shiny applications that our water quality assessment staff use to visualize and analyze the water quality data. Once all water assessment data has been entered back into KEDS, our database, we can then generate an integrated report to be reviewed and then published out to the public. Next slide, please. So Scott and I work in the Blue Ridge Regional Office, or sort of this purple polygon in the middle of the state there. And we're the region with the largest and the deepest lakes monitored by DEQ in Virginia. And this monumental lake monitoring workload, we found an opportunity to pilot modernizing our data collection method using Survey 123. Now, we honed in on the lakes program as a good pilot test case for updating our data pipeline because the DEQ lake monitoring program exacerbates issues with paper data collection. Our lake monitoring protocols require us to measure a handful of field parameters across a depth profile. So that's taking measurements from the surface to the bottom of the lake at prescribed intervals. To paint a picture of what that's really like out in the field, think about a crew, 2 or 3 field staff sitting on a boat in the middle of a lake, direct sunlight, 90+ degree heat. They're out there handwriting multiple numbers, each with different decimal precision requirements. They're doing this for every meter of depth at a site. And for Blue Ridge Lakes, that's often 30 meters of writing multiple numbers that can take upwards of 45 minutes if you add in the amount of time it takes for our monitoring equipment to stabilize at each meter's depth. Now, any lake run includes usually about 5 to 9 stations. If you add in setting up our sampling equipment in the morning, driving out to the lake, launching the boat, driving between stations, driving back to the office and prepping the physical water samples that are in containers for shipment to the lab, then we ask our field staff to sit down at a computer with their bleary eyes and try to accurately retype these numbers, usually that their colleague with terrible handwriting wrote down. And that's just a recipe for transcription errors. Next slide, please.
Thanks, Emma. Hi, this is Scott Hassinger, and I'm going to take us into a little bit more detail on some of this traditional workflow. So I joined the DEQ in 2004, and as long as I've been in water quality, our main methods for data recording have relied on what you see here using a waterproof field sheet and a black ink pen. Most all of our programs focus on using multi-probe water quality devices that report certain field parameters, traditionally temperature, pH, specific conductance, and dissolved oxygen, and then physically writing those numbers down onto a piece of paper. To do that, field staff must watch the handheld device to ensure that the measurements are stable, and then read from that display and write it onto the form. I've used a few different types of devices in my career, and some common truths about all of these systems are that the displays are often small and the amount of data displayed can be overwhelming. You usually can't change the output of the display to align with what you see on your field sheet. And the screens in outdoor environments can pose additional challenges due to the glare, dust, and scratches that develop over time, and polarization of the screen. While data logging is often possible, reviewing that data usually requires a computer interface. Next slide, please. So here you see our paper forms, and some things that we really like about this way of doing business are that it is totally intuitive and proven to work. It requires very little training to provide consistent results, and often staff find a benefit saying that it helps them to remember and recall the data at a later time. But on the other hand, as Emma alluded to, I know my handwriting is terrible, and I'm not sure all my colleagues can read my data sheets. And yet sometimes when the data collection exceeds the rate of input into the database, someone else must be asked to help with entering the data. And even with good QA, this can obviously be another source for errors. I think it's true for most everyone that the faster you write, the worse your handwriting gets. So we also know that there are physical limitations to the rate at which we can record our data. Next slide, please. And then if we take this and consider the workflow as it pertains to emergency situations, there are even more limitations to note. What we see here in this picture is a field team of ours scanning a data sheet with a cell phone to email to partners in the investigation during a pollution response emergency. These kinds of investigations require speed, and this is where the paper forms really have trouble keeping up. All of the previous cons that I've mentioned get exaggerated in these environments, and ultimately the errors have even more consequences. Next slide. Okay, so we've gone out in the field and collected all the data, but to work with it, we're going to need to get it into our database. And this has been achieved by sitting down in front of the computer and typing those forms line by line into the database. It's very tedious and time consuming. And of course, even with great attention to detail, mistakes are going to be made. And so we've introduced another vector for errors to creep into the database. And most unfortunately for our efficiency, we spend a whole lot of time doing so in that process. Next slide. So here you see us operating as a field crew for the EPA NARS surveys, in which we have used iPads for surveying randomly selected sites on rivers, streams, and lakes for the past 10 years. At first, we weren't sure about the use of these iPads, but we grew to love it once we found it was able to keep pace and even speed us up. Data input required a little getting used to, but we quickly learned to record as fast as with paper, and the app helped us to make fewer errors at the same time. For us and our team, the pros quickly outweighed the cons, and that caused us to look at our own water quality programs in a different light. We began to ask ourselves, if we are able to do some of our most difficult field work using an iPad, could we stop using paper forms on our regular monitoring runs? Next slide, please. So as Emma started to discuss, here in the Blue Ridge Regional Office, we like to think of ourselves as an unofficial lakes region. And we have many deep lake profiles to record, over 20 lakes that we visit through our rotation. And we have both the largest and the deepest reservoirs in the state. So we knew that if we could speed up data collection and improve data integrity at the same time, this would be an enormous win for our program. We started to think through the logistics, and we thought it could be possible. And so that's when we reached out to our GIS and analytic experts to see what they thought about our ideas. Next slide.
All right. Thanks, Scott and Emma. I appreciate the context provided there. So we've just reviewed some of the historical methods for collecting water quality data in lakes throughout the Commonwealth, and specifically within the Blue Ridge Regional Office. We're going to pivot slightly to talk about analytics, administration, GIS, and OIS at DEQ. So OIS is the Office of Information Services. We are responsible for administering our analytical systems at the agency, among many other things. But today we'll be talking about these analytical systems. So wanted to introduce the program itself, OIS, because we'll be referring to OIS throughout the presentation. Here you see myself and Maddie. We are two members of the analytics administration group at OIS. Again, I'm responsible for administering the Posit environment. Maddie is responsible for administering the GIS environment. And I want to start with a brief overview of the legacy architecture of the Posit environment, and Maddie will discuss and showcase both the legacy and newer additions to the GIS environment. For context, with regards to how these environments have grown to be able to support some of the work that we're doing now with a more modern approach to water quality monitoring. So starting with the legacy R Posit environment. Our first instance of Posit Connect was introduced around 2019. This instance allowed our users to leverage RStudio to develop content, interacting with our enterprise database, and push that content to a single instance of Posit Connect. We have always used Posit Connect to host Shiny applications, Markdown and Corto documents, and also pin data. Pin data being objects, data containers that we can host on the server to speed up rendering times for Shiny applications and increase data availability. But we have always used our Posit Connect instance to share Shiny applications, Markdown documents with the broader DEQ. So we have a subset of folks at the agency that have or leverage R and RStudio to create content, and that content is shared more broadly through that instance of Posit Connect. Well, this was the legacy build or architecture of Posit at the agency. Over the past several years, 2 years roughly, we've grown analytics and specifically Posit and our GIS environment quite substantially through investments in enhanced architecture and also staffing resources. So you'll see we still have a user base of folks that are leveraging R on their desktops. I'd say that user base has grown with time. We are leveraging that enterprise database, but we have adopted GitLab across our environment. So folks that are publishing content to our internal test and production instance of Posit Connect are leveraging GitLab for version control for that content. You see that we have a test instance here in addition to a production instance. So we've doubled the number of instances that we have of Posit Connect, allowing us to stage content and develop and test content before we move it to our production instance. So we have the ability now to further interrogate content that's been developed, test that content, share it with folks before it's deployed to our production environment. With this, we've grown our analytics community. So we've developed tools, specific teams at the agency, in addition to analytics, like a broad analytics team to bring together folks that are using different analytical tools. And we've really placed an emphasis on the analytics community so that the distance between like the users of these tools and administrators is reduced. And the distance between users is reduced as well. We really want to facilitate collaboration among different analytical tool users. And we've seen a benefit from really fostering the growth of those teams. One other thing I'll add here is in the not so distant future, we're also looking to introduce a public facing instance of Posit Connect. So the growth continues in this environment. And I think that these enhancements are directly tied to our ability to develop a solution like we're discussing today. One other point to add in terms of the growth of analytics from the R and Posit side of the analytics shop is that OIS created a position that was directly responsible for administering this environment. That's the position I fill currently. So we've seen investments in hardware, software, and staffing resources. And in turn, those have allowed us to invest time and resources into projects like what we're discussing today. So here's just an example of a landing page for our Posit Connect instance. I think it's representative of the fact that we have grown to host more content and provide that content back to the staff that are interested in using our different Shiny apps and Markdown documents. With that, I'm going to go ahead and pass it off to Maddie Moore, our GIS administrator, who will talk about the legacy and more modern GIS environment.
Thanks, Joe. As Joe said, I'm Maddie. I'm the GIS administrator at DEQ. So in this slide here, we're looking at the legacy setup that we had. Initially, we operated on a test and production standalone ArcGIS server, and it contained both our internal and external GIS data sources. Our data editors were only truly able to edit data through ArcMap or ArcGIS Pro connected to feature services in the standalone server. And there was no real capability for content creation by folks in program areas. Next slide. So this is our modern setup. In 2023, we were able to procure an Esri Enterprise license agreement, which allowed us to really beef up our enterprise environment. We were able to develop a federated ArcGIS enterprise environment, so users can now create and publish content to portal. They have access to enterprise geodatabases through feature services for editing. They can use Survey 123 website for field data collection. We were also able to heavily increase the number of licensed users that we have in the environment, as well as add mobile worker user types, which we did not have access to previously. The new environment is really what has made it possible for this mobile data collection, because now the business can create surveys that we can then connect back to our Oracle Enterprise geodatabases for real-time editing of GIS data. Next slide. So here we're looking back at the legacy workflow, and the highlighted boxes that you see are where we've changed we're going to show the changed methods over the years. So it previously used a mix of SAS, Excel, Google Maps, and a little bit of R to work our way from monitoring to the integrated report. But next slide, we'll see the more integrations with Esri as well as more use of R. So in our current process, the monitoring plans and budgets are created using Quarto and distributed through Posit Connect. Then sampling routes can be identified using route layers in ArcGIS Enterprise Portal. A future goal here would be for us to utilize ArcGIS Navigator to be able to navigate to sampling locations. Monitoring runs continue to be scheduled in the Comprehensive Environmental Data System, or CEDS. The field sampling, now we use the Survey 123 surveys created by Emma to allow offline data capture with submission to the Enterprise Geodatabase. They're able to enter their data to the Enterprise Geodatabase through connectivity with VPN, since our portal is secure. Then QA/QC can be performed in R by querying the data from the Secure Feature Services leveraging our ArcGIS bridge. And then from there, we have the nightly extracts from the Enterprise Geodatabase using ArcGIS Pro's base Python libraries like ArcPy and ArcGIS API for Python. And we distribute the data to multiple tables within the CAD system to ensure the sample data reaches the appropriate lab with the required metadata on time. Monitoring data is then incorporated into water quality assessment Shiny apps hosted on Posit Connect. Water quality assessors interact with these Posit Shiny apps to complete their assessments. And then finally, the integrated impaired waters report is created, reviewed, and published. Next. And I'm going to pass it back to Scott to go into further detail of the survey portion.
Thanks, Maddie. Yeah, so now that we're able to use Survey 123 to make our data collections, I'll give you a quick walkthrough of what this looks like in comparison to what I showed you earlier. So here we see a user with the new survey. They're able to select one of our runs from a drop-down menu. They choose the run that they're on, and now another drop-down menu gives them access to all the stations that are contained within that run, as well as some detailed station information helping guide the user to the right spot for sample collection. They enter their collector initials, attach a date and time to the sample, and start filling out some metadata about the site. Then they can put in their field data. This is a lake profile, so we're already on meter 7. We move to meter 8. They put in some more data, and instantly at the bottom, they can visualize the profile of data that they've collected, so they know they have everything they need before they leave the site. And I want to give a huge shout out and thank you to Angie Reed, previous R consortium speaker, that helped Emma and I understand how we could achieve this profile here at the bottom.
Now on to using this data after it's already been collected and input into our centralized database. I'm going to quickly talk us through the water quality assessment Shiny apps that help our staff efficiently make these assessment decisions on our water quality data such that we can generate our integrated report. DEQ has adopted sort of a hybrid automated assessment process that leverages R to clean and compile data from a number of disparate data sources. Then we apply a series of functions that help suggest assessment results for our human water quality assessment staff to then review. Next slide, please. So these suggested assessment results are sort of brought to life for our staff through Shiny apps that efficiently compile this data through curated tables, plots, and map widgets. Here, what we're looking at is one station's worth of data for an integrated report cycle that's first organized by DEQ region and water quality assessment unit. These apps first provide sort of critical metadata about each station assessment unit and monitoring station to help contextualize the station-specific standards or criteria, as well as historical assessment results. Now we're looking through individual parameter modules that help our assessors visualize the raw data behind the suggested parameter assessment results. Using sort of interactive plotting and table features from R packages like Plotly and DT, our in-house water quality assessment developers can highlight features of the raw data that require that human attention to better interpret this natural phenomena. This hybrid approach to automation allows our team to optimize the efficiencies through this data intensive process, which has a really short timeline to complete. Next slide, please. So by embracing technological solutions to a number of real tight pinch points in our data pipeline, DEQ's water monitoring and assessment processes have transformed over recent years. Our monitoring plan and associated budget are created again through those automated processes in R and shared through our internal Posit system. The sampling run routes are optimized through Esri navigation tools, and field data are collected in that digital format and ported directly into our internal database, and thus eliminate that step for re-entry of data by humans multiple times. Next slide, please. All those changes are great to tell management, but as nerds, we really like to have some numbers to back us up. Our water quality monitoring and analytics team also, we just can't help ourselves. And after a successful first year using Survey 123 on just lakes in our Blue Ridge region, we expanded the use of Survey 123 data collection to nearly all of Blue Ridge's monitoring programs for 2025. So here we're looking at a plot that's overviewing the density and distribution of mobile sample collection since 2024. The darker red points are lake sites where we have about 1.5 years of Survey 123 data collected. And then our lighter dots are monitoring sites from other survey programs added to our Survey 123 collection methods this past January in 2025. So this data encompasses over 90,000 pieces of data collected across 225 unique sites during 657 sample events. Next slide. So quantifying the data quality improvements is really a tricky, challenging task because we don't have meaningful ways to tease out historical transposition errors from our database. Anecdotally, we can say that we know that transposition errors were occurring, and by eliminating the need to transpose information twice, we're effectively having the opportunities for these errors to sneak into our database. We've also found that the ability to establish numerical bounds on parameters in the data entry fields within Survey 123, those have just been a fabulous tool to help our staff QA their work in real time out there in the field. And with our survey development team working so closely with the field staff, we're continually able to find other opportunities to ratchet down on potential data entry errors and improve our survey experience and, of course, the resultant data quality. Next slide. So the efficiency upgrades, that's where we can really sell this project. We run a small study to calculate how long it takes our staff to re-enter data from paper field sheets back into our KEDS data system. And on average, staff can enter about 12 pieces of information a minute, typing manually from that paper again into the front end of our database. So by eliminating the step, and using the numbers we had previously, we've calculated that our staff have saved roughly over 127 hours, which is a big number, but also think that is strictly 127 hours of just data re-entry. So numbers that they've already written down once. And that value is just monumental for our program. Next slide.
All right, so taking a look at all of this work that's been done, I wanted to take a moment to review some of the catalysts of these changes, of which there have been many. This project and effort was program driven. The water quality monitoring program advocated for the resources they needed in the field to bring about these efficiencies and enhancements. In communication with our analytics team and community, we were able to work towards a solution using Survey 123, the Esri environment, and Posit Connect, integrating these different tools. I would also say that the analytics community that we've developed has simplified the development and testing of this work, because again, the folks at DEQ through this community have a better idea of who to contact, when and where to get towards a solution. The DEQ has invested in enterprising both the Esri and Posit environments, as evidenced by the legacy and more modern architectures that we've stepped through previously. And DEQ leadership has supported and prioritized this work throughout the effort. So, implementing testing, this took a lot of collaboration and in the field time with the WQM program. And DEQ leadership has been supportive of the time required to make these changes. So taken together, there's been a lot of investment around all of these different items to move the method of data collection forward at the agency. So looking ahead, where do we take this next? One of the first items is we're looking at moving our data management workflow into the targets package, which is a package that does a really good job of automating and structuring data management pipelines. It allows us to better document those pipelines and reduce the time required to step through data management workflows. So that's something we're excited to look into in the near future. We're also interested in using geofencing and routing. So geofencing would allow us to, when in the field, have a better idea of our relative location when compared to a sampling station. So you can imagine being, in a boat and seeing the sampling location and using your relative location to navigate closer towards that station point. Also looking at further leveraging routing to execute sampling runs. So identifying the most efficient route to get to multiple stations during a sampling run. We have and are expanding Survey 123 usage to additional monitoring programs, both within the Blue Ridge Regional Office, but also across regions in the Commonwealth. We started with this as a pilot project, and we're looking to grow this as a tool throughout the agency. And another area we're looking to move forward in would be integrating Posit and Esri using API keys. That's something we've been working towards here recently, and that would simplify our staff's ability to pull data from the Esri environment into our Posit environment. Using API keys is a much simpler approach. So taken together, we have many avenues to continue working here and continue improving this overall effort and approach to collecting data at DEQ. So that's all we have for today. I want to take a moment from all of us here presenting it from DEQ and thank our consortium for having us on. Thank Esri and Posit for their feedback throughout this process, and certainly thank everyone on this call who we've been collaborating with, and all the folks at DEQ who have put in the time and effort to stand up this new approach. It's been an extraordinary effort, and as we can see, we've seen many of the benefits. So we're all looking forward to the future of this technology at DEQ.
Joe, thanks so much. Thanks for the acknowledgments. The feeling is mutual. This is a very interesting real world case, and it's great to see it in action and get all this information. We've got some questions that have been coming in. I'm hoping that we could respond to them now live. I'm going to read them out loud, and then I guess you guys get to fight over who wants to do the response. I'm going to start with one from Tim. This was already answered by Maddie in the Q&A window, but he has a follow-up. So I think I'm going to ask this out loud. Maddie, maybe you respond to it again or add something that goes beyond text. But anyway, there's a follow-up as well. So is it a one-way trip from the enterprise GDB to KEDS where it undergoes QA/QC? Or do the QC fixed data make it back to the GDB? If I understand correctly, where QA/QC takes place.
Yeah, so the enterprise geodatabase, like they can QA/QC before the nightly ETL happens using the ArcGIS bridge. But once the ETL happens and it's in KEDS, everything has to be done through the KEDS user interface. There's unfortunately, no backwards action at the moment. And yeah, I think that answers the question, I hope.
Okay, fantastic. And then Tim asked after that, does KEDS ingest the spatial data from the GDB also?
In this case, no, but in other cases, it would be possible. But in this case, all we're passing is just strictly attribute information.
All right. Tim's saying thank you. So I think you're on the right track. We have a question from Zachary. Are you all utilizing the scheduling tools in Posit Connect to automatically update data and analyses on a regular schedule? If so, how do you like it? Do you find it easy to use?
Yeah, I can take that one. We definitely leverage schedules in Posit Connect. I'd say the primary way we use schedules in the Connect environment is to refresh pinned data sets. We oftentimes will curate pinned data sets through Markdown documents. So say you have a Markdown document that's deployed to the Connect environment. It includes descriptive text, but also code to wrangle your data. So pull in from the data source, format your data, make those changes that you need to get the data into an end state, and then pin the data to the Connect server. And so in that Markdown document, you can schedule it to run at some interval. And I'd say that's our most frequent use case. There are other instances, like we mentioned the monitoring plan here, the beginning point of the effort in collecting water quality monitoring data, determining when and where and the expenses related to water quality monitoring. That's an instance where we use a schedule to run that monitoring plan every 2 weeks roughly. And the monitoring plan is developed during a set time period, but during that time period, it's running every 2 weeks. And that report is then shared over email from Connect to relevant managers and staff. So that's another example that isn't necessarily tied to generating data, but is like a report that we use in this process. And I'd say we have a number of schedules that are running every morning in Connect, and I think we leverage that utility very well.
Okay, fantastic. Thank you. We have another one from Anonymous. Does DEQ have a public GitLab that can be shared?
Yeah, I can take that one. Not currently. We only leverage an internal GitLab instance.
Okay, there are a couple more here. This is from David. I imagine it's a fairly long and possibly also ongoing practice to go digital, but can you pinpoint the toughest component to digitizing data in your workflow?
Maddie.
I would say keeping everything secure is our one of our larger issues. Having to use VPN to be able to pass the data from the field into our secure environment has been a struggle for us. Emma, you have anything to add?
I just would like to give a nod to the analytic structure at DEQ. As Maddie alluded to, the infrastructure and the security component is a whole mess. And it is a lot to manage. And thankfully, we have a Joe and we've got a Maddie to help us out with that process, which allows the rest of us sort of field/data nerds to do what we do best, which is try to find these tools to integrate into our centralized systems. So I think it's hard to conceptualize transitioning some of these processes, but by letting the people that know how to do the work and collect the information how it needs to be done, having that nice bridge with our analytics team that can help bring these ideas to life, it's made these transitions as easy as possible, even with all the security things.
Fantastic. Thank you. We do have time. Yeah. Okay. Go ahead, please.
Just to add to that, I think part of the challenge, and we're hearing it echoed here, is trying to integrate this tool with some architecture that's older, right? That isn't necessarily able to be updated at this point in time. So we're having to integrate with multiple different environments that are all in different stages of development. And I think in any institution, that's going to be a challenge. But Yeah, having the ability to interface with the folks in the field who are doing the testing development, making recommendations, getting that feedback quickly, and having the infrastructure to go and make the changes on the architecture side that we can manage. I feel like that's been helpful as well.
We have another question from Anonymous. Are you aware of other state agencies that are currently leveraging Posit?
One state that we've been talking to recently, I know Arizona, their DEQ has an instance of Workbench, which is a slightly different product than what we have, which is it's a whole suite of tools that one can use from a centralized, internal R type of server. That's one we can point to, and they've got great examples of all the work that they're doing with R using that system.
Yeah, I'm having a hard time of thinking of a Virginia agency that's using Connect. Certainly, federal agencies are. USGS, EPA engage with Connect to some degree and develop Shiny applications.
Okay, we have time for more questions if there are any. I don't see any coming in. We'll give it just one more minute. I think having the moderator asking a question is a little painting outside the lines, but since we have a moment, I'm curious about sort of before and after. Do you have kind of a feel for this is a process? I imagine it's ongoing, but from paper to digital, do you have a sort of number how long it's taken?
I guess we started thinking through these processes in 2022, sort of springtime, to give you a general idea. We tried a first iteration in the field season of 2023, just again for our lakes in the Blue Ridge region, using not Survey 123. And then since 2024, and about in April, that's when we brought the Survey 123 process online. So part of that has to do with just certain times of year we're collecting this type of data and sometimes we're not. That also allowed us to have some time to think about how to best improve some of these processes as they apply to first our lakes program. And then after it was quite successful, trying to apply them across the board to other monitoring areas. And I'd say across the board, the rest of the state has been watching us, take these battles on and interested in seeing the results. And our next challenge is how are we going to implement this at a wider scale? Because I think we've proven it to be successful enough at this level. Bringing something like this to a wider audience will bring its own challenges in it. But I think we're probably up to the task. I think we got this.
That's great. Okay, I don't see any more questions coming in, so I think we're going to wrap it up here. The R Consortium provides free webinars related to R information regularly. Please take a look at our webinars page. On Monday, in fact, we have the health technology assessment. One of our working groups is having a morning webinar. And so if you're interested in how R works in healthcare, that may be of interest. I want to give a big thanks to the Department of Environmental Quality speakers, Joe, Maddie, Emma, Scott, thank you very much. And also our experts from Esri and Posit. Thank you for your time and effort, and especially to our audience. Thanks, everyone. We're going to wrap it up here. Thank you very much.